So I used this word stack a couple times when we were looking at this. The stack is basically just the location in memory where the interrupted method calls are stored. Java actually has to go and store all that stuff in memory. So those are the commands it hasn't gotten to yet. Once that base case is hit and it stops the repetition, the program moves through the stack and carries out all those commands. So let's look at another example. Here we've got public static void recur, and you'll notice in here it's calling itself recur1. There are two general types of problems you're going to see on the AP. Sometimes they'll say, in the following recursive method, and usually they'll have some kind of name like recur or mystery or something like that. And those are usually pretty easy because they're telling you, hey, this is recursion, trace it. The other type of problem you'll see, though, is they'll say public static void mystery, and then in here there'll be a call to mystery, but the description of the problem won't say recursion. So sometimes you are expected to recognize, hey, that's recursion, even though the problem itself doesn't say that. So here we have public static void recur. We have our int coming in. We want to look and see what the if statement's doing. So once in hit 0, this is going to stop. And then we're printing into the screen. And again, there's no L in here, so it's all happening on one line. Now on the AP exam, usually they're going to give you some kind of starting value. So we're doing recur1 of 6. So again, please, please, please write this down. N starts off at 6. So again, we have our two chunks here. We have the if statement and then our output. And those output commands are going to go over here and get stored in our stack until we're ready to finish up the recursion. So the first time in at 6, 6 is greater than 0. So the recursive call is taking 6 and subtracting 2. But first, it's printing out the n. So the very first thing to get printed is this 6, and it's just sitting here waiting in the little bucket. The recursive call does n minus 2, so the next time through, n is going to be 4. So we go through. 4 is greater than 0. So it stores 4 in the stack, and then it does recur with 4 minus 2, which gives us 2. 2 is greater than 0, so we put 2 in the holding pen, and then we do recur again with 2 minus 2, which gives us 0. Now, before you get into these, you always want to stop and look at your base case so you kind of know what your target is. Otherwise, it's kind of easy to sort of get enthusiastic and keep rolling and forget to stop. But this stops when n is less than or equal to 0. So we've hit 0. That means our next time through the recursion is going to stop. That's our target. So n is 0. 0 is not greater than 0. So at that point, the recursion stops and we hit the system.out.print 0 on our monitor. Now it goes back through those stored commands. So the next thing, and notice there's a little space here in between, it prints a 2, a 4, and a 6. So a couple fun facts about recursion. Recursion is basically a shortcut. It's used when you want to simplify a really complicated algorithm, and that algorithm can be repeated on smaller and smaller sets of data that are similar. So for instance, when we started with 6 and then 4 and then 2, we had a very easy pattern that we were following. And any recursive method can be rewritten as a loop, just sometimes those loops are going to be really long and almost impossible to actually type out in code. So again, just to go back, on the AP exam, the expectation is you can read recursion. So you'll see a few recursive methods on the multiple choice section. You'll need to recognize it, but you don't actually have to write recursion. So today's lesson introduced the idea of recursion. Again, it's just a way of repeating commands, but using the method to call itself instead of something like a while or a for loop. If you want to see another recursive joke, just go to Google and type in the word recursion. See if you can catch the joke.